Hi everybody, I am Vinod and we are discussing computer integrated manufacturing. It's a topic in manufacturing engineering. Computer integrated manufacturing. So it's a manufacturing approach of using computers to control the entire production process. And instead of manual process, if you use computer for from the starting to final product, then it is called CIM. So here this weightage for this computer integrated manufacturing is in get you may get 0 to 3 marks. Mostly you will get 2 marks question. Sometimes even they may not ask questions also. Book you need to refer: CAD-CAM by P. Groover. First topic in computer integrated manufacturing is basic concepts of CAD-CAM. CAD-CAM is a part of the computer integrated manufacturing. So first one is CAD. What is CAD? CAD is also known as computer aided design. Is also known as computer aided design and drafting. Computer aided design and drafting. So CADD. In CAD we use computer for designing and analyzing the component. Suppose if you want to design a nut or bolt, so we use computer instead of machine drawing. We use computer for drawing this. So the advantage of CAD is it takes less time, and you can change modification. You can do modifications very easily. But if in machine drawing, like manual drawing, if you want to do modification, you have to draw new drawing. That's one of the advantages. So it saves time, it saves labor, lot of advantages. It has few steps in computer aided design. First one is recognition of need. First you have to know what you need to do, what you need to draw. Second step is problem definition. Problem definition, suppose for example I want to design wheel. So that is for what? Recognition of need means here if you want to design for a wheel for two-wheeler, that is a recognition of need. And problem definition is like what is the diameter, what is width, all those parameters. And next, synthesis. Synthesis is also called geometric modeling. Here we start modeling in computer based on the parameters which we have defined in problem definition. Next one is analysis. So whatever we design, we do analysis like stress tests. So how much stress it can withstand, that material. All these things we use in analysis. Next, evaluation. This is the final step in the computer aided design, where you can check whether it meets your requirement or not. Evaluation. These are the few steps. In computer aided design, many commands are available for drawing basic geometric shapes. So if you want to draw a circle, you will have circle template, or if you want to draw a square, you have square template, and you can give the length and width for if it is rectangular template, if it is square, circular template, circular. If you want to draw a circle, it has circular template, which helps which increases the fastness of drawing. In computer aided design, you first start any drawing with vertex, which is called one single point. Next, if you combine 2 points, it is called edge or line. If you combine few edges, then it will form surface. If you combine few surface, it will form solid. So this is the process you have to follow in any design. If you look at the gate old questions in your gate material, gate 2009, ME 2009, the question they asked is, which of the following is the correct data structure for solid models? He has given options: A, solid part 2, solid and faces and edges and vertices, and option B is solid, edge, face and vertices. Option C is vertices, edge, face and solid. Option D is vertices, face, edges, solid. So any diagram starts with vertex, then edge, and then surface or face, it's also called face, and then it will be solid. So ME 2009 question, answer is C. So if you want to develop a solid model, you have to start with vertex, then if you combine 2 vertices, it will form edge. If you combine few edges, then it will form face, it will be solid. So for example, this is vertex, combine 2 vertices, it will be edge, combine 2 edges, it will be surface. So this is one more question in GATE 2009. Next, there are different types of designing, like there is one type of method like boundary representation, BREP, which is also called BREP, boundary representation. Boundary representation is a method of representing shapes using the limits. Suppose for example, a solid is represented as a collection of surface elements. Now we have discussed that a solid is formed with few surfaces. So each surface acts as a boundary. There is another method is called constructive solid geometry. It is used in solid modeling only, and it is used to create complex shapes by using Boolean operations. It is used to create complex shapes by using Boolean operations. What is meant by Boolean operations? So plus, minus, addition, subtraction. is called Boolean operation. In constructive solid geometry, CSG, which is also called, we use simple solid shapes like pyramids, circle, sphere, solid shapes like sphere, square, pyramid, cylinder, these shapes. When like except so there are other shapes, and you can subtract one shape from the other. This is called constructive solid geometry to form the new shape. So this is one way of creating a new design. One is boundary representation, another one is constructive solid geometry. So out of all this, we actually there are few special curves which are made for designing curvature. One method is by using mesh. So curvature design, first method is using mesh. Mesh is combination of multiple rectangular or square shapes. Suppose if I want to create a curve shape, then I will start combining straight lines. Like for example, here this is a curve, so this one first I will just draw the outline, then I will draw similar lines. So this is called mesh, perpendicular to those lines. So this is one way of drawing curve shapes. Another method, there are few templates which are called, one is Bezier curve or B-spline curve. Bezier curve or B-spline curve. It is defined by its order and set of control points. So it is defined by its order and set of control points. Control points P0 to Pn. Suppose for example, if you want to understand it clearly, if I want to form a line, suppose if there are n equal to 2, that means number of points equal to 2, then it forms straight line, right? Join these 2 points P1, P0 and P1. Suppose if n equal to 3, then it is quadratic equation. So suppose the curvature will depend upon the location of the third point. So initial point P0, final point which is called P2, and second point is P1. If the P1 is here, the curvature, it won't touch it will touch only, the curve will pass through only initial and final point, and it won't pass through the points in the middle. So the curvature will vary if the point is here. Suppose for example in this case, if the point is somewhere here, then the curvature will be like this. So if you want to increase the curvature, just increase the distance between this middle point and the remaining points. So this is called Bezier curve or B-spline curve, which we can design curve shape components with the help of points, number of points. If you increase the number of points, curvature complexity of the curvature will increase. By increasing number of points, the complexity of curvature will increase. The degree of curvature will increase. This is one method. Another method is there is Kuhn surface. Kuhn surface, which actually especially used for automobile bodies, car bodies, four-wheeler any bodies. So the surface, curve surface is designed by using Kuhn surface. It is one template which is generated with the help of 4 lines or 4 curves. Earlier we have discussed in Bezier curve or B-spline curve is formed by points. Similarly, Kuhn surface is formed by 4 lines or 4 curves. So this one, curve 1, curve 2, curve 3, curve 4. These 4 curves will form the Kuhn surface. So the length or distance, the length of the curve, each curve, if you change the length of the curve, and the curvature will change. So it is formed by 4 bounding curves. Because they all form as a boundary of the total curvature. That's why it is called 4 bounding curves. So if you look at the GATE question, GATE ME 2008, the question they have given is, for generating a Kuhn surface we require. The question is, for generating Kuhn surface we require, so what we have discussed, we require 4 bounding curves. So that is option C. For generating Kuhn surface we require, options are, first option is a set of grid points on the surface. Second option is a set of grid control points. Third option is 4 bounding curves defining the surface. Fourth option is 2 bounding curves and a set of grid control points. So if you look at the first option, that is called Bezier or B-spline curve answer. So out of all the options, only option C is satisfying the answer. So C is the answer. Kuhn surface is formed by the 4 bounding curves. Next question. If you look at GATE 2000, ME 2000, ME 2000, in GATE material question number 14. The question is, in computer-aided drafting practice, arc is defined by. Question number is 14. In computer-aided drafting practice, arc is defined by. Generally, arc is defined by what? Suppose, what is arc? You need 1 point, another 2 points, or 1 arc. So here options are option A is 2 end points only. So 2 end points we cannot form arc. B. Center and radius. With only center and radius we can't form arc. C. Radius and one end point you can't form arc. And D. Two end points and center. So these are the two end points A and B, and this is the center. So if you have two end points and center, then you can form arc. Simple question, without with common sense you can answer. So answer is D. Next topic is computer aided manufacturing, CIM. As of now we have discussed computer aided design and drafting. So now computer aided manufacturing. So in this, instead of in CAD we have used computer for drawing purpose, but here we use computer to control machine tools. So use of computer to control machine tools. This is called computer aided manufacturing. So all manufacturing operations are controlled by using computer, like drilling, turning, all these operations you can, if you control with computer, then it is called computer aided manufacturing. So what is the advantage of computer aided manufacturing compared to manual manufacturing? So main advantages, if you use computer it will be fast. One is advantage, accuracy will increase. Used for mass production. If you want to produce more products, you can use computer aided manufacturing. And minimum wastage. Why minimum wastage is because if you do manufacturing with manual intervention, there may be errors, but if you use computer, there won't be errors, will be very less, so minimum wastage will be there. Next is types of machine tool control. Machine tool means machine. Types of machine tool control. First one is numerical control. So in numerical control, it is the oldest method where they used punch cards as an input for the machine. So whatever the command if you want to give, you will punch on the card based on the diameter of the size of the hole. The command will be, it will automatically send the signals, so the machine manufacturing process will take place. So in numerical control, punch cards or magnetic tapes are used as input to the machine. Punch cards or magnetic tapes are used. So it is numerical control is a form of programmable automation in which program is coded into punch cards. So here whatever program you want to write, program is coded into punch cards. These punch cards are also called as magnetic tapes. Punch cards or magnetic tape, both are same. So here punch card is generally they are prepared with paper or plastic paper or aluminum foils. Punch cards are made of paper or plastic paper or aluminum foil. Punch cards are fed into control units. punch cards fed into control unit, and this control unit reads the punch card and converts into mechanical signals. So it will convert into mechanical action of the machine. See, punch cards are here, punch cards are fed into control unit. Here these punch cards are fed into the control unit, and this control unit converts this punch card to mechanical actions. So the machine will produce do the mechanical operation according to the punching sequence of the holes. So in punch card it is, for example, it will be like that, so punch card, small holes will be, you have to punch. So based on the diameter and size of the hole, so it will read automatically whether it is diameter, what is the operation you need to do, whether you need to do turning, whether you need to do drilling, and what is the diameter of the drill. All these, it is predetermined. Based on the diameter it will read and it will convert into mechanical actions. This is numerical control. Here manual entry is there, so you have to feed the punch card into the control unit. And if you want to modify, modification is difficult, modification of a program is difficult. So if you want to change the program, and if you want to increase another operation, then again in the middle, then you have to go for new punching paper. This is one drawback here, and it will take long time to go for punching lot of paper on the paper. If it is complex shape, you need to punch very huge paper, so it takes time and it's a waste of time. So this is oldest technique, now nobody uses this one. Next one is CNC, computer numerical control. Computer numerical control. Instead of punch cards, here we write program in computer, so which controls the mechanical operation. It is called computer numerical control. This is used in mass production, and it's very easy to do any complex shape, so we no need to go for punch card here. Machine tool is controlled by computer. By using computer. So this CNC, computer numerical control. There is another method, DNC, which is called, there are two names for DNC. One is direct numerical control, or distributed numerical control. Distributed numerical control. Here the program, if the program is huge and memory is less in that computer, then it is the entire program is stored in separate computer. So then you can control the number of computers with the help of single computer. The program is stored in separate computer. The program is stored in separate computer which is used to control multiple machines. Instead of single machine, multiple machine tools or machines. So this is distributed numerical distributed. So many machines you are controlling with one single computer. Like if you can control drilling and milling and as well as lathe, all these three machines if you are controlling with single computer, then it is called distributed numerical control. Next topic is machine tool control movements. So machine tool control movements, there are two types. So one is point to point control. First one is point to point control movement. Here the machining takes place only at particular points. Machining takes place instead of taking continuous machining, like suppose for example in drilling. So machining takes place only at particular points. That's why it is called point to point control. Machining takes place only at a particular points. Example, drilling. Boring, reaming. Here suppose if I want to drill two holes for here, suppose hole A and hole B. So machining takes place only at particular A and B only. So in the while that the tool is traveling from A to B, there won't be any machining takes place. So that's why it is called point to point control movement. So machining action takes place only at particular points. For example, in this case machining takes place only at A and B. So in the middle there is no machining. The tool will be idle and it is moving. So next one is continuous motion. Continuous movement of tool. Continuous movement is again two types. So here machining action takes place continuously without any break. So the two types here is one is straight line motion, another one is curvilinear motion. Straight line motion and curvilinear motion. So first is straight line movement. The tool moves parallel to one axis. In straight line movement, the cutting action takes place, or cutting tool moves cutting action takes place parallel to one axis. It may be x axis or y axis or z axis. So there is only straight line movement of the tool, cutting action. For example, turning in turning, tool moves straight line axis to the spindle. Turning is simple example. Next, another one is contouring. Here cutting tool or cutting action takes place in more than one axis simultaneously. Cutting tool motion is more than one axis. So it is called contouring. For example, suppose if you want to create curve, then it is called, suppose you are producing a curve here, contouring. So the values in x and y axis varies. So the curve AB, the tool is moving, cutting action takes place from A to B. So the values of x and y axis varies continuously while it is moving from A to B. So that's why the tool is moving along two axes simultaneously instead of one axis. That is called contouring. Example, milling. So milling is helical shape. You have to gears you have to produce. So milling is one example for contouring. So GATE 2007. So there is GATE 2006 question. In material it is 8th question. ME 2006. Question number 8. Question is, NC contouring is an example of. So as we have discussed, NC contouring is an example of. First option is option A, continuous path positioning. Second option is point to point positioning. Second B is point to point positioning or point to point movement. And C is absolute positioning and D is incremental positioning. So absolute and incremental we will discuss after this topic. So here option continuous path positioning is contouring. Contouring is curve shape. So option A is correct answer. Answer is A. Similarly, if you look at the 9th question, which among the NC operations given below are continuous path operations? So continuous path operations. So options are given like arc welding, that is GATE 2006. This is ME 2005. Sorry. So options are arc welding, next one is drilling, next one is milling, next one is punching in sheet metal, next one is spot welding, laser cutting of sheet metal. So So these are the options they have given, and in A option they have given arc welding, laser cutting and milling. B, arc welding, drilling, laser cutting and milling. C, drilling, laser cutting, punching and spot welding. D, drilling, laser cutting and spot welding. If you look at the options, he is asking continuous path operations. So if drilling is present in B, C, D options. Drilling is point to point positioning or point to point operation. So A is the answer. So you can eliminate the options, remaining options. Elimination procedure you can use here. Next topic is interpolation. So interpolation, which tells the movement of the tool from one point to another point. So interpolation is the method of continuous movement of the tools. It may be like movement of the tool from one point to another point. Movement of tool from one point to another point. This is called interpolation. So here there are different types of interpolation. One is circular interpolation. Linear interpolation. Linear interpolation. So if the tool moves linearly, it is called linear interpolation. Second one is circular interpolation. If the tool moves circular shape, then it is called circular interpolation. If the tool moves helical, then it is called helical interpolation. If the tool moves parabolic, it is called parabolic. There are so many different interpolations like this. Okay. Next topic is NC part, numerical control part programming, which is called NC part programming. Now it is most important for GATE. You will get 2 marks question. In most of the years you will find the 2 marks question from this topic. See here, the programming is like our C language. Here also for machine language is there. It is called NC part programming. We have specific codes for each operation. Like if you want to start the machine tool, and it has to turn clockwise or anti-clockwise, it has to move straight line. For all these, each operation there is one specific codes. So these are specified in different categories like G codes and M codes. So these are all used in machine NC part programming. There are few definitions which we need to remember. One is block. So block means is a collection of group of commands representing single instruction. Group of commands representing single instruction. Anyway, I will explain it clearly after once you know the commands. And there are 2 types of programming. One is absolute programming and incremental programming. absolute programming. Another one is incremental programming. So absolute programming, it code tells the computer to measure from fixed point. You have to measure the distance the tool, distance traveled by the tool from a fixed point. So distance traveled by tool is measured from fixed point. Absolute programming. And incremental programming is distance traveled by tool is measured from the current position. Distance traveled by tool is measured from current position. So the code G90 tells absolute programming. Tells the values are measured by absolute programming or from absolute zero. G91 tells G91 is used for incremental programming. Incremental programming. I will explain you in detail what is absolute and what is incremental. For example, if you take one diagram, so for example, tool travel is from A to B. This is origin 0, 0. This is A and this is B and C. So tool is moving from starting point O to A and A to B, B to C and C to D. This point is okay. So this is a simple example which explains you absolute and incremental programming. So if you take absolute programming, you have to measure all values from fixed point origin. So fixed point is origin. First tool movement from O to A. The code is we have to write N01 G90 N01 G01 G90 X0 Y5. So here few things you need to remember. So N01 represents operation sequence number. N01 operation sequence. So O to A is the first operation, A to B is the second operation, B to C is the third operation, C to O is fourth operation, like that. So next, G01 is code for straight line motion. Straight line motion. G90 is for absolute programming, as we have discussed. If you look at x value, x is 0 and y is 5. So that means there is no movement on x direction, only the movement is only in y direction. 5 units the tool has moved in y direction. Okay, and this is from O to A. Similarly, from A to B, absolute programming. The sequence operation number 2, straight line motion, G90 absolute programming. So you have to measure from starting point x5 y5. So these values are measured from origin. So similarly for B to C, like that you have to write. So in the same way, if you write incremental programming where the reference point varies every time, incremental programming. So here, for example, O to A in incremental programming. So both absolute and incremental are same in O to A because it is the first point. Origin is fixed. I mean, like reference point here is same in both cases. But A to B is different. It is N0 second operation, straight line motion, G91, sorry, please correct it. It is G91 is for incremental programming, and in incremental programming you have to measure from A to B. See here it is A to B, so A is reference point and B is the final point. You have to measure the distance from A. So from A, X is increasing 5 units, Y is 0. There is no increment in Y. So similarly from B to C you have to write. If you observe the difference between absolute and incremental in A to B, there is the measurement values only the vary. I mean the difference is the measured values from fixed point.